Dear students and my teacher friends, Namaskar. I welcome you to the presentation lecture on digestion in the stomach. Now, as you can see on the screen, I am showing you one concept map for the digestion process that is taking place in the stomach. Now, the figure that I am showing you right now, this figure or this concept map is covering most of the theory points in this presentation lecture. This is the half part of this concept map, and this one is the second part of the our concept map. So I request you that you go through this concept map because this concept map is very important, and this one also, this part also. Now lecture will start from point number 1, but before point number 1, the introduction that I am going to give you, that is very important. From point number 1, the lectures will become easy. So first of all, you listen this introduction that I am telling you. Now here, first you read this, the title of figure, that is the neural and hormonal control of the stomach. Now over here, as you can see, this person, let's say this person is eating something and he started the chewing of food in his mouth. Now by the time this person is chewing the food in his mouth, that time from this person's brain, vagus nerve transmits nerve impulse to the wall of the stomach. So this process, this transmission of nerve impulse from vagus nerve to the wall of the stomach, this transmission is known as the cephalic phase. Okay, now due to this transmission of nerve impulse from the vagus nerve, even before the person has swallowed his food, the gastric secretion start in his stomach. This is the one point. This is regarding the cephalic phase. Now moving on to the gastric phase. Now what happens to gastric phase? Now here, as you can see, the person has swallowed the food. So now the bolus has reached into the lumen of the stomach, and this bolus is applying pressure. This bolus, this food is stretching the wall of the stomach. So due to this stretching, the G cell, they produce the hormone gastrin. So over here you can see there are two mechanisms. One is meandric reflexes, and the second one is the vagal reflex. Now what is the vagal reflex? So the nerve impulse from vagus nerve, it transmit into the wall of the stomach, that is called vagal reflex. And what about the meandric reflex? Now in the wall of the stomach, digestive nerve plexus is present. And this digestive nerve plexus is present in the form of nervous tissue. This nervous tissue controls the movement of the wall of stomach, esophagus, and intestine. And this tissue, this nervous tissue, is known as the myenteric plexus. And this myenteric plexus, which is a nervous tissue, it is situated, it is present between the circular and the longitudinal muscle in the wall of the stomach as well as esophagus and intestine. So now we have two things. One is the stretching due to the food, and second thing, the nerve impulse from the vagus nerve. Okay, and the third thing, that is short myenteric reflex. So this three factor, the food stretching the wall of the muscle, nerve impulse from the vagus nerve, and the myenteric reflex, combinedly these three, they are inducing the gastric gland to secrete gastric juice. This is one thing. Now, as you can see, this person has ingested the food. Okay, now when he has ingested the food, the pH in the stomach is 1 due to the HCl, which is present in the gastric juice. Now what this food is doing, so this food is buffering the acidic pH, or we can say the food is neutralizing the acidic effect of the HCl. So now as the food is buffering the HCl, what happens? The pH is elevated, and this elevated pH stimulate G cell. As you can see with the arrow, it is shown that the G cell of the gastric gland, they are induced, and once they are induced, this G cell, they secrete the hormone gastrin. Now what this hormone gastrin is doing, so the gastrin inducing the secretion of histamine. Now which cell they are secreting the histamine, and what is this histamine is? Now in the stomach, endocrine cell are present, and this endocrine cell, they are known as enterochromaffin like cell. In short, this cell, they are known as ECL cell. Along with ECL cell, the mast cell and the neurons, they secrete the histamine. But the question is, when they are secreting the histamine? Now the ECL cells are peptide hormone producing cells. Okay, and this ECL cell in the mammals, they are present in the basal region of the oxyntic gland area and in the chief cell region. Now the parietal cell, they predominant in the mid region, okay, in the gastric gland. Now this ECL cell, they respond very quickly to the hormone gastrin, and this ECL cell, they releases histamine. Okay, once they empty their histamine, then they will resynthesize the histamine again. So the ECL cell, they are fulfilling the important requirement of the digestion in the stomach, that is the secretion of histamine. Okay, so this is how the histamine is secreted. Now we are having histamine is secreted. Okay, and the gastric hormone from the G cell is also secreted. Now what this histamine and gastrin is doing, so they are stimulating acid and enzyme secretion. Now which are the acid and which are the enzyme? So now coming on the first point of our discussion, now the lecture will be very smooth. Okay, now first, pepsinogen secretion. Now which are the factors that is inducing the secretion of pepsinogen? So pepsinogen secretion is stimulated by, number one thing, vagal stimulation, vagal nerve impulse, then the hormone gastrin and the histamine. These three factors together, they are promoting the secretion of the pepsinogen. Now which are the cell, okay, that produce, that secrete the pepsinogen? First of all, what is pepsinogen? Now the pepsinogen is an inactive enzyme, or we can say it is the precursor or the pro-enzyme of the pepsin. And this pepsinogen is mainly secreted by the cheap cells of the main gastric gland. So cheap cells are secreting the inactive pepsinogen. Okay, then small amount of pepsinogen is also secreted by the pyloric gland. Now the pepsinogen which is secreted by the cheap cell is called pepsinogen 1, and the pepsinogen which is secreted by the pyloric gland is called pepsinogen 2. So we are having pepsinogen 1 and pepsinogen 2. Now here you can see in this figure, this is the this one is the, as you can see, the gastric gland is shown and the cheap cell. I am zooming this so that you can observe this properly. And the cheap cells, they are secreting the pepsinogen. Okay, now moving on the third point of our discussion. Now in this point, now pepsinogen is synthesized, pepsinogen is produced and stored as the zymogen granules. And where these zymogen granules are stored? So they are stored in the apical region of the cheap cell. So now this point is regarding the zymogen. Now what happens? The many digestive enzymes, when they are secreted, they are in the inactive form. And this inactive protein enzyme, they are known as the zymogen. And then they are converted into active enzyme by the removal of some of their amino acid. So zymogen is the inactive form of enzyme, And by the removal of some of the amino acid, they are converted into active form. Now, in the stomach, cheap cell secrete the zymogen, and that is known as the pepsinogen, and the hydrochloric acid is removing some of its amino acid and converts it to the pepsin. Now here in this figure, as you can see, due to the effect of the hormone gastrin, the G cell, the G cell, G cells are secreting the hormone. Sorry, the G cell are secreting the hormone gastrin, and we know how this gastrin is secreted. Okay, which are the factors responsible for this gastrin secretion. So what this gastrin is doing, so now you can see over here, this gastrin is affecting the parietal cell, and the parietal cell, they are secreting the HCl. Okay, this is how the HCl is secreted. Now what this HCl is doing, okay, so here you can see the cheap cell has secreted pepsinogen, that is inactive enzyme, and it is known as zymogen. HCl, what this HCl is doing, it is converting this pepsinogen into active pepsin. But how? See, this is the pepsinogen, inactive enzyme, and this HCl is breaking the peptide bond within the amino acid. So this fragment of amino acid is detaches from the inactive pepsinogen. Now as some amino acids are removed, so this pepsinogen is converted into the active pepsin. Okay, so this is how this active pepsin is produced. Now here in the fifth point, as you can see, zymogen, pepsinogen, the name is written, and this pepsinogen is acted by HCl. So by the removal of amino acid, this pepsinogen is converted into the active pepsin enzyme. And what this active pepsin is doing? So this active pepsin is acting upon the remaining pepsinogen, and it is converting this remaining pepsinogen into pepsin. So this is the excuse me. So this is the fifth point of our discussion. Now the ultimate function of the pepsin, what this pepsin is doing. Now the food that we eat, in that food the proteins are present, and this protein are known as the dietary proteins because they are present in our diet. So this pepsin is acting upon the dietary protein, and this pepsin is converting the dietary protein into the shorter polypeptide chain. So pepsin is basically breaking the, or we can say that it is degrading the dietary protein, and it is converting the dietary protein into the shorter polypeptide chains. Now here you see the mechanism of pepsin, how the pepsin works on our dietary protein which are present in our food. So this pepsin breaks certain peptide bonds which are present between the amino acid. Okay, so we know in the structure of protein there are many amino acid, and in between the amino acid there are peptide bond. So this bond of the protein, which is the peptide bond, is broken down by the action of the active enzyme pepsin. So here you can see the smaller fragments of polypeptide are shown. So the large protein molecule, by the action of pepsin, is converted into small fragment of protein by breaking the peptide bond. So this is the 7th point of our discussion. Okay, this thing we have learned, okay, how this pepsin is activated and what it is doing. Now moving on the eighth point of our discussion. Here also, as we now know, the pepsin is acting upon the dietary protein. So it is splitting the protein, and the small amino acid fragments that are produced, they are known as the proteases, peptones and polypeptides. So in the structure of proteases, peptone and polypeptide, there are basically the amino acids are there, but they are the smaller fragment of the original protein. Now here it is important to note that the optimum pH, the ideal pH for the action of pepsin is 2.0. So it is very important that the secretion of HCl is maintained throughout the process of digestion in the stomach. So the HCl secretion is basically maintaining the acidic pH, which is very important for the digestion of protein. So this is the function of pepsinogen. Now moving on the 9th point of our discussion. See, we are in our daily routine life, we used to drink milk. Now in this milk, water soluble protein is present, which is known as casinogen, and this casinogen is actually a milk protein. Okay, now in humans, what happens, this soluble milk protein, which is casinogen, is acted upon by pepsin, and this pepsin converts this soluble casinogen into casein. Now what happens to casein? Once the casein is produced due to the action of pepsin on casinogen, this casein combines with calcium and it forms insoluble calcium caseinate. This process is known as the curdling of milk. So once the milk is curdled, again on that curdled milk, the pepsin, okay, curdle milk, and this pepsin is acting on curdled milk, and it is converting this curdled milk into the polypeptides. So this is what the pepsin is doing on milk protein in humans. Now, in case in other mammals, let's say in the cow, in the deer, in the camel, the curdling of milk is carried out by the enzyme renin, which is present in the gastric juice of these mammals. Now, what this renin is doing? See, renin is also known as the chymosin. It is a protein digesting enzyme and it curdles milk by converting caseinogen into insoluble casein. And this renin is present in the fourth stomach of curd chewing animals. Now, what is the meaning of curd? Now, let's say in the cow. See what happens once the cow engages the food, she starts chewing, and then the cow swallows food. They swallow food, enter into stomach, and then after 1 or 2 hours, this chewed food from the stomach once again enter into the cow's mouth for further chewing. So this is the meaning of curd. Okay. Now here the action of renin is shown. So in other mammal, the renin converts soluble milk protein caseinogen into casein, and this casein is acted upon by pepsin in other mammals also, and finally this casein is converted into polypeptides. So this is the meaning of this point. Now moving on the 10th point of our discussion. Now the main function of pepsin is to digest the dietary protein in our food. Okay, and now we know protein is partially digested, so it is in the form of proteoses, peptones and polypeptide. So this proteoses, peptones and polypeptide, once they are formed, they enter into the small intestine for the further digestion. So in the small intestine, the digestion of protein is completed. Now this point, gastric lipase. Now cheap cell, they also secrete the enzyme gastric lipase. Now this gastric lipase, okay, along with lingual lipase. Now we know the lingual lipase with a small salivary gland which is present in our tongue. So cheap cell, they are secreting gastric lipase, and lingual lipase, they are secreted by this enzyme, are secreted by the small salivary gland of our tongue. Together they are involved in the splitting of fat. Now the fat, see, 10 to 15% of our dietary fat is digested in the stomach. Now what this gastric lipase is doing? What is the action of gastric lipase? See, the fat that we eat or the oil which is present in our food. So basically it is in the form of triglyceride. Now, what is triglyceride and how it is formed? For example, over here, this one is the molecule of glycerol, and these are three fatty acid. Let's say this is fatty acid 1, this one is the fatty acid 2, and this one is fatty acid 3. So these three fatty acid, they combine with the glycerol, and by the process of dehydration, that means the removal of water molecule, one molecule of triglyceride is formed. So in the structure of triglyceride, what is present? One molecule of glycerol is there, and 1, 2 and 3 fatty acids are there. And now what this gastric lipase, which is secreted by the chief cell, is doing? So this gastric lipase is breaking the bond of the triglyceride. So here, as you can see, these two fatty acids are removed. This is actually the ester bond, and the gastric lipase is breaking the ester bond of the triglyceride. Okay, and as the two fatty acids are removed, so here we are having one glycerol molecule which is attached with one fatty acid molecule. So one glycerol molecule which is attached to one fatty acid, this structure is now known as the monoglyceride. So here we can say, due to the action of gastric lipase, triglyceride are converted into monoglyceride, which is having one glycerol molecule, and to that the one fatty acid molecule is attached. So this is the 11th point. You can go through this point number 11. Okay, now this monoglyceride and along with the undigested triglyceride will enter into the small intestine for further digestion of the fat. Now moving on the 12th point, this point is something related with the intrinsic factor. Now, which cells are secreting the intrinsic factor, and what is the intrinsic factor? So parietal cell, they are also secreting the glycoprotein, and this glycoprotein is known as the intrinsic factor. Now what this intrinsic factor is doing? See, in our food, vitamin B12 is there. So this intrinsic factor combines with this vitamin B12 and it is forming a complex with vitamin B12. Now this complex is absorbed at terminal ileum. Okay, that means the end part of the small intestine. Okay, now the secretion of the intrinsic factor is the only indispensable function of the stomach. Now what is the meaning of this line? The secretion of intrinsic factor is the only indispensable function of the stomach. That means this function of producing the intrinsic factor is something not involved in the digestion process. That's why this function is known as indispensable function, and actually it is involved in the process of absorption. Now how this complex is absorbed by the terminal part of small intestine. So it is absorbed by receptor mediated endocytosis process. Now if the intrinsic factor, let's say in a patient or a person, in which the intrinsic factor is not secreted. So in that case, what will happen? So in the deficiency of the vitamin B12, in the absence of vitamin B12, hemoglobin cannot be synthesized in that person. In that situation, that phenomena or that disease is known as, that condition is known as pernicious anemia. Now, sometimes what happens, due to some infection, the patient needs to perform the removal of the stomach. That process is known as gastrectomy. Now, even if the stomach is removed from the person's body, it is not that the process of digestion will stop after the surgery. Process of digestion will take place, will continue in the small intestine. But the thing is, since the intrinsic factor has gone, this cell, parietal cells are not there. So once we remove the stomach from the patient's body, this intrinsic factor is not going to secrete it. So in this condition, vitamin B12 by injection or in the form of the tablet is given to that person. Okay, so this is regarding the intrinsic factor. Now moving on the last point of our discussion. Now stomach, this is something, this point, if we want to absorption in the stomach. Now very little absorption is carried out by the stomach because the epithelial cells are impermeable to most of the material. Okay, however, the mucous cell of the stomach, they absorb some water, ions and short chain fatty acid as well as certain drugs. For example, aspirin and alcohol is absorbed by the stomach wall. Now moving on the 14th point of our discussion. Now within 2 to 4 hours after eating a meal, the stomach empties its content, that is the digested food in the stomach. Now it is emptied into the duodenum, which is the initial region of the small intestine. Now, so in the digested food of the stomach, there are carbohydrates are present, there are proteins are present, and fats are present. Now the question is, among these three component of the digested food of the stomach, which one enter first into the duodenum? So here we are remembering that the carbohydrate very quickly they enter into the duodenum because there is not much digestion of carbohydrate is taking place in the stomach. Then from the stomach, the fat which is present in the form of monoglyceride and triglyceride, this fat will enter into the duodenum. And finally, after spending much time in the stomach, the protein which is in the form of proteases, peptones and polypeptide, this will enter last into the duodenum. Okay, so basically stomach is digesting the protein. Okay, little bit digestion of fat is taking place in the stomach. So this is the 14th point of our discussion. Now 15th point. Now 15th point is related with the function of HCl, what the HCl is doing. First of all, HCl is producing the acidic medium in the lumen of the stomach, and this acidic pH or this acidic medium is killing many microbes, many pathogenic bacteria. They are killed by HCl. Then HCl partially denatures or unfolds the proteins in our food, and at the same time HCl also stimulates secretion of hormones. In this hormone, they are promoting the flow of bile and the pancreatic juice. So hormones which are involved in the flow of bile and pancreatic juice, these hormones are induced by HCl. This point again it is repeated. HCl participate in the breakdown of protein, provide the optimal pH for the action of pepsin, and hinders the growth of pathogenic bacteria. Now, before I wind up this presentation lecture, one figure I would like to show you. This is not in your syllabus, but you can go through this figure. It is very small one. For example, vagus nerve, branches of vagus nerve, and these are the cells. Okay, they are shown, and their secretion. Okay, so now we know histamine. Okay, so histamine, from this figure you can make out that the gastrin is acting upon ECL, and the nerve impulse from the vagus nerve is also responsible for the histamine secretion. Then G cell, they are secreting gastrin. Okay, and gastrin also affecting D cell, somatostatin, and all this thing, histamine, gastrin, somatostatin here minus negative feedback effect, and this they are vagus nerve impulse, histamine and gastrin, they are giving the positive feedback on the parietal cell. So the parietal cell, they are secreting H plus and Cl minus. So in this way the H plus Cl minus combine and HCl is formed. So I am showing you this figure. Okay, so this is the vagus nerve, these are the cell, and this is the, okay, this is how the HCl is secreted. So with this I have completed this presentation lecture regarding the digestion in the stomach. I hope you have enjoyed this presentation lecture, and at the same time I hope this presentation lecture will be helpful in your exam preparation and in your studies. My name is Manish Koshti sir. I am from Ahmedabad, India. Bye bye. Namaste.